Hello, I'd like to explain my implementation of Conway's Game of Life. It's a simulation where a grid of cells evolves based on simple rules. Some cells are alive and some cells are dead, and they change over time based on their neighbors. So as you can see in the code, the program uses a grid made of squares. Each square can either be alive being 1 or dead being 0. And I set the grid size to 50 times 50 and made each square small enough to fit the entire grid on the screen. So when the program starts, the grid is filled randomly with alive and dead cells, as you can see the code over here. And this ensures that every time we run it, the starting pattern is different. And for the rules for the cells, each square looks at its neighbors, and there are 8 around each square and decides what happens next. If a square is alive but has too few or too many neighbors, it dies. And if a square is dead and has exactly 3 alive neighbors, it comes back to life. And if I try to run the code, as you can see, I use SFML to show the grid on the screen. Each square is drawn as a small rectangle, and the black cell for alive cells and white for the dead cells. And the grid updates every 200 milliseconds, so we can watch the changes as it happen in real time. And also I added a pause feature, so pressing the space bar stops the simulation and pressing it again resumes it. This makes it easy to stop and take a closer look at what's happening. So overall, this project shows how simple rules can create interesting patterns in behavior. It's a small program, but it demonstrates the basic of how systems like this work. Thank you.